The paper of the day is Larger Than Memory Data Management on Modern Storage Hardware for In-Memory OLTP Database Systems. This paper presented policies for managing cold data storage in an in-memory DBMS. Paper outlined policies that are both independent and tightly coupled to the underlying storage technology. Paper then evaluated these policies in the H-Store DBMS using 5 different hardware devices. Their results show that tailoring the strategy for each storage technology improves throughput by up to 3 times over a generic configuration. Paper found that smaller block sizes and synchronous retrieval policies are generally good choices for storage devices that have low access latencies such as SSD, 3DX, and NVRAM. Limiting the number of cold tuples that are merged back into the table storage is effective on reducing the throughput oscillation. Finally, the performance of the DBMS with NVRAM can be as good as with DRAM if treated correctly. Paper uses the YCSP workload which comprised of 90% read transactions and 10% write transactions. They start with comparing the cold tuple retrieval policies like abort and restart, AR in short, and synchronous retrieval SR in short. They also vary the size of eviction block for each of these two policies. Paper measures the performance of the DBMS using all best policy configuration for each storage device on other OLTP workloads. The workloads are voter. This benchmark simulates a phone-based election application. It is designed to saturate the DBMS with many short-lived transactions that each updates a small number of tuples. The second one is TPCC. This benchmark is the industry standard for evaluating the performance of OLTP systems. Then third one is TATP, TATP. This last workload simulates a caller location system used by cell phone providers. Now let's look at the contributions of the paper. Paper identified policies that are crucial to the performance of an OLTP DBMS with a larger than memory database. To evaluate these design choices, they implemented all of them in the H-Store DBMS and analyzed them using different OLTP workloads. They deployed the system with 5 different storage devices that all have distinct performance characteristics: STTD, shingle magnetic recording or SMR in short, NAND based SSD, emulator for 3DX point-like technologies, and byte addressable NVRAM. Their experimental results show that by properly accounting for the hardware's properties in the DBMS for cold data storage, they can achieve up to 3 times higher throughput. Now let's talk PS score for this paper. Overall, this paper is a decent read, so it gets 9 out of 10 on readability. With 7 pages long, it scores 7 out of 10 on length. It's a measurement paper with pretty good description, so that makes it 9 out of 10. Its industry value and learning meter is decent, so it gets 8 out of 10 on each. Overall PS score is 8 out of 10.